Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. So this problem is from an audience, and actually the audience asked me a question to find a solution that without using the rotation. Well, I didn't find one because this just remind me something. Let's continue discussion and I will explain it. So the first part is problems that asked by the audience, and the second part is problems that remind me. Okay, so let's see the first problem here. Given an equilateral triangle ABC, let a point P to be inside the triangle ABC with AP equals to 3, BP equals to 4, CP equals to 5. Find the length of side of the triangle ABC. It's obvious that 3 squared plus 4 squared equals to 5 squared, right? So we want to find a right triangle, basically. And we just need to find how to make that right triangle. But let's just draw an equilateral triangle first. So call it ABC here. And let's say this is 3, 4, 5. This is point P, right? And we want to find the length of the side of the triangle. And the solution that I can figure out is pretty straightforward. Just rotate the triangle APC by 60 degrees. So we have let's call this new triangle to be BQC, right? We just rotate triangle APC by 60 degrees. So we know that this angle equals to this angle, which means this one is 60 degrees, right? The angle QCP equals to 60 degrees. And we already know that QC equals to CP equals to 5. So this is 5, this is 5. That means, and also we know that angle QCP equals to 60 degrees. That means the triangle PQC is an equilateral triangle, right? Which means QP equals to 5. This one equals to 5. That means this is 90 degrees, but we may not, that means this is 90 degrees, right? That would be useful here. So this is 90 degrees, 3, 4, 5, this is 90 degrees, and then we can calculate for BC. Set this as alpha, we know this is 60 degrees, so we know that BC squared equals to BQ squared plus CQ squared minus 2 times BQ times CQ times cosine angle BQC, right? And it equals to 3 squared plus 5 squared minus 2 times 3 times 5 times cosine angle BQC. Angle BQC can be written as angle alpha plus angle alpha plus 60, right? So that's cosine alpha, cosine 60 minus sine alpha, sine 60, right? So it equals to 3 squared plus 5 squared minus 30 times cosine alpha. Cosine alpha equals to, because this is a right triangle, right? That's 3 by 5. So 3 by 5 times cosine 60, that's 1 by 2 minus sine alpha. Sine alpha is 4 by 5 times sine 60. That's square 3 by 2, right? So it equals to, see here, this is 10. 30 divided by 10, that's 3. 3 times 3, that's 3 square. So we have 5 square plus this one here, 30 divided by 10, that's 3. 3 times 4 times square 3, that's 12 square 3. So it equals to 25 plus 12 times square 3, which means the length of the side equals to square root 25 plus 12 square 3. Okay, that's the length of the triangle, the side of the triangle. I'm not sure if I can find another solution without using this rotation, because this is too straightforward. I keep thinking of using this one, so I didn't quite find another solution that we can simply get the very elegant solution, simply get the length of the side without using this rotation. Okay, and because of this, it reminds me another problem that actually associated to the centroid we just discussed a few videos before. Now let's look at this problem. M is a centroid of triangle ABC, and AM equals to 3, BM equals to 4, CM equals to 5. Find the area of triangle ABC. Notice that AM squared plus BM squared equals to CM squared, right? We discussed about the properties of the centroid, and in that video, I think one of the property of the centroid is that if you find this thing, right? We know the centroid and the distance from the centroid to the vertices can form that AM squared plus BM squared equals to CM squared. That means the median from A to the opposite edge and the median from B to the opposite edge, they are perpendicular to each other, right? So let's just draw a perpendicular line first, and then try to, so this would be A, okay, this would be B, here is C, right? And this is M. So we know that AM is 3, BM is 4, right? So AM squared plus BM squared equals to CM squared. CM is 5, right? And we want to calculate the area of the triangle ABC. Because AM is perpendicular with BM, so we know that AB equals to 5, right? Well, it's not, this is not very useful information here, but let's see. We already know that M is a centroid, right? So we got, let's call it, okay, this midpoint is E. So ME equals to half of BM, right, equals to 2, which means the area of triangle AEB equals to half of AM times EB, right, equals to 0.5 times AM is 3 times EB is 6, so it equals to 9, which means the area of triangle ABC equals to twice of area of triangle AEB equals to 18, right? Okay, for both problem, I want to express the point that once we see such thing in a problem, the easiest way is to form a right triangle, right? Otherwise, how can we use this? Right, to find the right triangle. Okay, I hope you like this video. See you in next one. Thank you.